So anyway, we'll start with a couple of homework problems. One was to estimate the distance traveled from t equals 0 to t equals 1 with a delta t of 0.2 if the velocity is 1 over 1 plus t. So what we want to do is, what we can do is we want to evaluate the function v of t at between 0 and 1 at this interval of 0.2. So we'll start off with t equals 0. And when t equals 0, v of 0 is 1 over 1 plus 0, or 1. So I'm just going to go through and evaluate the function 5 times, because the point delta t of 0.2 from 0 to 1 will give us 5 intervals. So when t is equal to 0.2, v of 0.2 is 1 over 1.2. So it's at 5/6. You can just use decimals, but what you'll need to do is look at what the answer is called, what's called for in the answer, and make sure you go farther than that. If it says round your answer to the nearest 100th, you should probably take this to the nearest 1,000th at least, and use that in the interim. Or it could be like all fractions, but then you have these fractions and decimals mixed together, and so that's kind of annoying. So 1 over 1.4, we'll do it 10 over 14, or 5/7. So just do this for each of the t values. Oops, no, that's going to be 1/2, isn't it? So just do this for each of the t values, and then use these values to approximate, do an overestimate or an underestimate. Now, what we could use, since we have these 5 points, we can use 1, 2, 3, 4, 5 rectangles. Sorry, 6 points. So we're going to make rectangles where the delta t is 0.2. So that's where we're going to get our width, the width of each of these rectangles. And the v of t will be the height of each rectangle. And we can either use the left endpoint or the right endpoint. So if we use the left endpoint, our delta t is 0.2. In this first rectangle, the v of t is 1. The next rectangle is 5/6. The third one is 5/7. The fourth one is 1 over 1.6. So 10 over 16, 5/8. Note that we're not using the 1 because the v of 0.8 and v of 1 are 2 ends of the same rectangle. And I pick one of those ends. And in this approximation, I'm using the left endpoint. And then we can go through and get an, this will be an overestimate since the function is decreasing. And then we can just do the same thing for the right approximation. In this case, we'll look at this first rectangle 1 is on the left and 5/6 is on the right, so we'll use that, the one on the right. 5/7 is on the right of the second triangle, sorry, rectangle. 5/8 is on the right of the third. 5/9 is on the right side of the fourth, and 1/2 is on the right side of the last one. One thing to note about the units and what we're actually measuring is that this 0.2 is being measured in seconds, and each of these velocities is measured in centimeters per second or whatever it was. So if I multiply seconds times centimeters per second, I end up with centimeters. So the units work out. The time is measured in seconds, and the velocity is measured in meters per second. So when I multiply those two, the seconds cancel out, and that tells us that we're measuring a displacement or a distance. Any questions? Now, in this case, if we actually wanted to approximate distance, and we weren't told specifically to evaluate it ever with 5 rectangles, so a delta t of 0.2, we could just use our calculator and integrate this from 0 to 1. But this is a problem from 5.1, and we haven't learned definite integral technology. But this is Calc 2, and you've seen this technically in Calc 1, so this is kind of a review. So on your calculator, you could say do FNINT. So to get this command, you go into the math menu, you press the math button on your calculator, which is funny because it's a calculator and they're all math buttons. But you pick the one that's specifically labeled math, and then scroll down to, I think it's choice B, FNINT, because we want to do an FN integral. So that's under the math button. And there's specifically a math menu, and I think it's choice, is it math? No, it's 9. I think it's 9. FN integral. The syntax for doing a definite integral on your calculator will be to put in the function. So the first thing we'll list is the function. We got to punch in single line syntax for the function, so we're going to need to use some parentheses. And then we put a comma. Right above the top row of numbers is a comma. And then you tell the calculator what the variable is, even though you just use the variable right here. You got to tell the calculator dx, so that comes next. So you put in x. And then you put a comma. And then you put in the interval over which you would like to evaluate this integral. So from 0 to 1, 0, 1. So from 0 to 1. And then you close parentheses and hit enter. Now this will not be the same value that you got for left and right. Left and right use 5 rectangles. Pretty poor resolution. And when you plug in the calculator this way, it does many more rectangles. It does you enough rectangles so that your left and right are accurate to 12 decimal places, because that's how many your calculator can keep track of. It's just doing the calculations very fast. Any questions? So you should know that your calculator can do definite, it can numerically approximate definite integrals. This is why I like having this particular graphing calculator, the TI-84, because it's very good at doing things like numeric approximations of definite integrals. Strangely enough, we refer to it as our graphing calculator, and it is a terrible graphing calculator. If you want to actually produce graphs, it is terrible at producing graphs. Mostly because when we're doing homework, we probably have a computer sitting right on our desk, or even we have a phone and a better graphing calculator is Desmos. Because that's free. All you need is a $1,000 phone to make it run. But it's called Desmos. Is anybody unfamiliar with Desmos? So Desmos is a better graphing calculator. Oops. I had to blur out this graph because it's kind of pornographic. I'm just kidding. There's just a light there. And it's better because all the things that you would want to do on your graphing calculator, you can do on your phone, because your phone has a screen that works in a more tactile way. Any questions? Comments? All right. So Desmos, much better graphing calculator. You can also just go to desmos.com. Instead of using the app, use your browser. Is everybody okay? No, always keep your old calculators. Because the new calculator should do all the stuff that your old calculator does, but you might forget, and the new calculator might have different functions. So in a pinch, just grab your old calculator. Somewhere up in my office is my calculator that I had in high school. And all the writing has worn off, and it had all the buttons were printed on a metal plate that was glued on top. That fell off. So I just have to remember where the buttons are. So I'm old enough that my class in high school was the first class of freshmen that were required to have a calculator, a scientific calculator to do the science classes. That was the first year. But I'm not so old that I know how to use a slide rule. So I'm trying to figure out where things fall in history. I do not know how to use a slide rule. So there. All right. So in this problem, what we have is a function that goes up a little bit. And it drops down. And one of the tricky things about this problem is that they made the graph, for some reason, they decided to make the graph kind of difficult to read. I mean, like, use a bolder line for your axes. But here's the t-axis, and then here's the v-axis. And it tells us that a is equal to, it changes, but in this one, a is equal to 1 and b equals to 5. I wish they would stop making a equal to friggin' 1. Here's how it really annoys me. Because we'll do stuff later on, and they'll say, it's 0 to 1 in both directions. So you're supposed to integrate from 0 to 1. But how do I know if you just didn't automatically integrate from 0 to 1 because it's in both directions? Make one of them from 0 to 2, and the other one from 0 to 3, so that I could see if you understand where you're ending. This is why I have a restraining order. I'm just kidding. I don't have a restraining order. I've not been, but they don't return my calls. Like, oh, what's with this 0 to 1 business? Knock it off and hang up. Maybe that's why they don't call me back. So what we want to do, here we have the velocity during a trip starting from home. Positive velocities take you away from home, and negative velocities take you toward home. So this is a function that's telling us velocity. Here's time in hours, and here's velocity in kilometers per hour. So this area that we have above the t-axis and beneath and under the graph of the velocity, this area is going to be the amount of area that we drove away from home. So this area up here is going to be the distance traveled as we were driving away from home. When the velocity reaches 0, we are neither traveling away from home nor towards home. So you can think of this as where we're turning around. Here's where the kids finally got to the parents, and the parents said, all right, that's it. We are turning this car around. And then negative velocities, we're returning, heading back towards home. So that's what's going on. That red area would be how far we are from home when we turn around. The purple area is how much we've headed back. So here are positive velocities taking us away from home. Here are negative velocities taking us towards home. The area tells us by how much. This goes along with our derivative thinking. We're looking at this graph. It's a graph of velocity. Velocity is the rate of change of position. So this is a graph of our change in position. It's the graph of the derivative of our position. Positive means the position is increasing. The distance from home is increasing. When the velocity or the derivative is negative, that means that the position is decreasing. So we're headed back towards home. And it looks like we did not make it, at least not on this graph, as the area before we turned around is greater than the area after we turned around. If we had another kind of question that said, how far did we drive on this trip? Then we would want to take this positive area and then the absolute value of this area down here. So as an area, this would be positive, but the definite integral is going to call this negative because the function is decreasing. So if this is 12 miles this way in this positive area, and there's, say, 5 miles that are below, we would say that we are 12 minus 5, 7 miles away from home. Oh, sorry, kilometers. Modern. We're 7 kilometers away from home at this point. We've driven a total distance of, what did I say, 12 and 5? We've driven a total distance of 17 kilometers. The real trick in this problem is knowing how to approximate this. And I think I was able to get the answer that that Canvas wants, or that Wiley Plus wants, by just reading this as a triangle and then reading this as, I broke it down at the high points and just said a triangle on this side, and a trapezoid on this side. So. Question? So this is the kind of annoying thing about doing problems on computer. Because the person that wrote this problem, it was very obvious that this high point happened at like, whatever it is, I can't even see it anymore, that this was 3.8 and not 3.5. And then they put in a tolerance for the problem of plus or minus 2%. A tolerance of plus or minus 2% doesn't matter when you're rounding things to the nearest unit. That means you have to get it exactly. There's no point in saying there's a tolerance of 2%. It's like, oh, so I have to get it exactly. What's this can of soda cost? Rounded to the nearest dollar, you have an error margin of 2%. That means you don't have an error margin. That makes sense? This is why I don't just like arbitrarily decide things. This is clearly written by someone who doesn't understand percent. I know they think they do, but they don't. I mean, it's percent, per 100, divide by 100. It's just right there in the name. You know what I mean? So many people be walking around saying they understand percent. Well, how many of your students passed? 60%. Wow, that's a big class. It's like, well, no. There are only 12 people. Then don't give me percents. They're meaningless. You know what I mean? It's pretty questionable if I use a percent in this crowd. Because there's 40 of you, 44. Not in the room today. You know what I mean? This is how you can tell if someone understands percent or not. Give them a problem in percent. If they can do that, give them a problem that just uses parts per million, ppm. If they're like, oh, well, now I don't know what to do. If you can't fix that problem by just saying, do the same thing you did before, only million instead of cent. If they're like, oh, I still don't know. They don't understand percent. You know what I mean? Same thing happens in this class, because you all been through algebra. And what that means, since you've all been through an algebra class, is that you're not very good at algebra. I'll say it. There is so much algebra that you did not get to learn about. And the algebra that you did get to learn about, first of all, is probably pretty niche. And second of all, you didn't get to the point where you were proficient in it. You got to the point where you were proficient enough to get through the class and have the teacher say, okay, you are approved for the next class. I think it's really important that, especially if we give a student an A, all right, you got an A in Calc 2, you are approved to go in Calc 3, but I need you to understand that you are super deficient in your Calc 2 skills. At the end of this semester, you're going to be really good at integrating functions, not because it's an important skill to have in the grand scheme of things, but it's one of the skills that we acquire in Calc 2. And that's probably the best you'll ever be at integration. I only need to get you good enough at integration. I can't make you good at integration. That takes too long. That makes sense? Second of all, you don't need to be. For the most part, people don't get into integration bar fights anymore. So it's like that scene in Good Will Hunting, only instead of talking about economics, you get into integral fights. Integral fights are way more serious because there is an antiderivative. It's not just economic theory that we're arguing over, which is essentially, what do we call it, voodoo. I can't say BS in class, so especially if I'm being recorded, I can't be like all bullshit. So I just switched it. Oh, dang it. I also don't edit my YouTube videos. But no one's watching them anyway, so it's okay. Any questions? Comments? People are like, oh, Leach, you can't be swearing in class. What are you talking about? I just did. No, you're not supposed to. It's unprofessional. Well, I know. Been here for 20 years. You haven't noticed that I'm unprofessional yet? Pretty slow on the uptake. Question?
Yeah, so
Okay, yeah. So if you want to find the area between the curves, what you got to do is find out where they are the same. So if you want to find the area between the curves, what you got to do is first figure out where the curves intersect. I'm just going to draw a generic. So I'll have, let's say, one curve. And then some other curve. So we want to find the area below f of x, but above g of x, instead of just above some interval in the xy plane. The first thing that we need to find this area. The first thing we need to figure out is where the graphs intersect. If we're not given x coordinates, our first job is to find where the graphs intersect. So we just take f of x and set it equal to g of x. And find the solutions to this equation. If I recall correctly, we had a combination of a rational function and an exponential function, which means there's no way to solve this by hand. You have to use a machine to do it. So if you have a mix of an algebraic function and transcendental function, you're not going to be able to solve by hand. You don't have a technique for that. So just take these two equations. You can graph them on a graphing machine, not your TI-84, because then you have to figure out where you have to tell the calculator where you want to look. You do this on Desmos, and then you can just move around to where you want to look. But all you have to do is click on the intersection points and find out where they are. But the first thing, you got to find the intersections. Those will be the solutions to f of x equals g of x. Then what we need to do is length times width, because all we ever do for area is length times width. And then now I just suddenly regret shading this in, but that's okay. The length that we're going to use is not just the function, but the distance between these two functions. So our width is some change in x, and our height is f of x minus g of x, the difference between these two functions. So your height is going to be f of x minus g of x. So our area will just be the integral from a to b of f of x minus g of x dx. And since at this point in the problem will be on calculator time anyway, you might as well just use a machine to do it. So grab your TI-84, do the math 9, and then just put in f of x minus g of x. Any questions? Yes. You should, when you're looking at the graph, the one on top, do the top one minus the bottom one. That way your answer will come out positive. If you get the order backwards, if you put g of x minus f of x, all that will do is change the sign. Because if we just change the order of this subtraction, that'll just change the sign. 5 minus 2 is 3. 2 minus 5 is negative 3. So switching the order in a subtraction problem just changes the sign. So it's not a big deal. Any other questions? How's everybody okay? Everybody looks stunned. You all look like this. Because it's our first Monday. Starting on Tuesday is good because then the first week of class is short, it's only 4 days long. And you get a whole week for up to being having like a Monday. How's everybody okay? Weird. Normally you come in like on a Monday and talk about some kind of television show that happened over the weekend. That always happens to happen in pocket. But the problem is television shows just happen all at once now. So I don't know what your strategy is, but I wait till there's a lot of episodes of a show. So like The Mandalorian is out. I'm not watching it in the first week because they're only giving us like 2 episodes. And I'm like, oh, what the heck, Disney? Just give us all the episodes. Because I'm just gonna wait until they're all there anyway, in case I sit down and get so engrossed that I have to watch the next one. You know what I mean? I started watching Book of Boba Fett and not all the episodes are out. And I'm kind of annoyed now because I gotta freaking wait.
Yeah. My friends made me do it. I wasn't going to.
But yeah, but they're like, oh, hey, we're watching Book of Boba Fett. And like, oh no, you jerks, it's too early. I'm like, oh, we're gonna know stuff that you don't know. And you're like, well, dang it, now I gotta go freaking watch it. You know what I mean? I wasn't gonna watch the season 2 of The Witcher in one sitting, but what did I do? I watched season 2 of The Witcher in one sitting. And I wonder, how do I get so engrossed in a show that doesn't actually have a story? It's just like a bunch of things that are happening. You know what I mean? But there I was. It's one of those shows I'm like, I understand completely why I love the show. I'm like, I'm a D&D nerd, so obviously I'm gonna watch The Witcher and it's gonna be fun. But like the most iconic moments are essentially Henry Cavill getting annoyed and going, I was like, what was the best line from season 1? I mean, those are your highlights. And then it's like, oh, you describe it to someone else and they think you're a crazy person. But you're like, oh, no, seriously, it's Henry Cavill. And he's like annoyed and he goes, It's amazing. What are we talking about? Oh, yeah. The guy that made Downton Abbey is making another show, but it's set in America. And so I have a feeling, like all these imported shows, it's gonna be worse. You know what I mean? That's not completely true. Like, I don't know, there's like a lot of shows that were imported that had to be changed. Like American audiences can't really watch the British version, the original British version of Shameless. Because we wouldn't understand their references. It had to be moved to America for an American audience. Because then they could do all the lazy stuff and not have to explain things. And they say, well, instead of being set wherever the heck it is in England, that means nothing to me. They say we're going to set it in the south side of Chicago, and that communicates a lot of information as to an American view. You know what I mean? Yeah. I think it's got, yeah, that it has to be changed because in England, there's going to be elements of office culture that Americans don't have access to. And I'm pretty sure you can't take the office from America and send it back to England and have them watch it. Because there's going to be elements of American office culture that they just don't have. That make sense? But then there was a show called Being Human. Has anybody seen that show? Of course not. This class is way too small to find anybody that's seen Being Human. But it was a show about a ghost, a werewolf, and a vampire living together. It was essentially a more interesting version of Friends because it's a ghost, a werewolf, and a vampire living together. That was not setting dependent. And yet they still tried to make an American version anyway. And the American version was colossally worse. Who knows why? Was it worse? I haven't seen the IT crowd. Yeah. And I think that show is going to land because the IT crowd is going to appeal to people that at least have that probably have some kind of connection to IT. Maybe you're the computer person in your family, something goes wrong with your grandma's computer, and you're the one that everybody freaking calls. I happen to be the youngest person in my family, so I'm the one they call. I don't know jack about computers. I just want to tell my mom and dad, so I go, Mom, Dad, I have a MacBook Pro. This is because I don't want to know anything about computers. And I don't. So don't ask me to fix your computer. I am completely unqualified to do it. They're like, well, yeah, but it says this. You just not listen. You know what I'm talking about? I don't want to know about computers. So I bought the Honda CRV of computers. And when you just put it on your desk, it costs too much for what you're getting, but it's going to be fine. It's going to do the stuff that you want it to do. It's not like I'm going to the track. It's not like I'm going off-roading. What are we talking about? Oh, yeah. So area between curves, we're doing the same thing. It's the important part is to recognize that we're doing the same thing. Length times width. Just the length is not the value of the function. It's the top minus the bottom, which is what we were doing before anyway, because it was the f of x, or in this case, v of t, minus 0. So we just didn't write that part. Top minus bottom. Top minus bottom. If the two graphs switch positions like they do here at B, and you're trying to find area, then you're going to have to calculate up to B, and you have to stop there, and then start up at B, and then go to wherever they end. Because as soon as they switch, g of x, f of x minus g of x is going to be negative. That's going to be like you're taking away from the area that you have here. So you want to make sure everything stays positive. How American is that? Stay positive. Cheer up. If you want to get punched in the face, find me when I'm in a bad mood and just tell me to cheer up. The last thing that you're going to hear before you get knocked out is, that's not how that works. It's like when someone's angry and you tell them to calm down. That's not how that works. No one would ever be angry if that was the case. Someone's like getting really angry and you're like, oh, calm down. Oh, whoo, thanks. All the anger is just gone because you told me to calm down. That's another way to get punched in the face. And so if you're angry and someone tells you to calm down, the last thing that they should hear before you knock them out is, that's not how this works. Anger is a perfectly valid emotion to have. Don't be just invalidating my emotions. That's a lot to say to someone before you punch me. But that's gonna do it for today. I'll see you all tomorrow. Everybody have a good day, and thanks for playing.